Hi, my name's Michael Lynn. This is going to be sort of the dark magic follow-up to Tim's talk that he just did. Python and Ctypes. I go by a lot of names online. So Frogger on Freenode IRC and the MacAdmin Slack. Recommend. It's great for online interactive chat with a whole bunch of administrators. A lot of people in this room here actually hang out there. I've been hanging out there during this conference. Pudquick on GitHub, and then Mikey on Twitter. And yeah, anyways, sorry about that. The names all happened to me before I started having a combined presence online. So anyways, this isn't a giant talk. This is sort of just a mini talk to get you kind of possibly thinking more in depth about options that are out there for using Python for Mac administration. It's just sort of a taste, kind of gets your appetite whetted. So as Tim was talking about with Python, it's a great language for Mac admins. A lot of projects are built into it. It's the batteries included that he was talking about. There's built-in libraries that do things like web URL access and working with JSON and data types that are really common out there. There's the plist lib that he mentioned in there for manipulating the ASCII plists, which unfortunately now is less useful because of all plists from are standardizing on binary from all Apple applications, but he covered the foundation plist and everything that handle that. It's built in, comes with your Mac. It's interactive if you want to try and learn the language and test things on the fly. You don't need Xcode and all the developer tools and all this crazy stuff installed to use the language because it's basically text at the core of it. It's an interpreted language. So whatever text editor you're comfortable with, you can use. You can use Vim, Emacs if you're that kind of person, or you can use TextStrang, whatever you're happy with. There's a lot of choices out there. And the default install of it that comes with OS 10 has the PyObjective-C, the API bridge in there. So you can automatically tap into a whole bunch of APIs that Apple provides for doing things to your Mac, manipulating all sorts of features and frameworks and whatnot. There's another layer beyond PyObjective-C, though, if you want to get a little bit more advanced, and that is Ctypes. So Ctypes is access to non-Objective-C frameworks. It is for like C language frameworks, sort of like Unix-style libraries. So in OS 10, the stuff that this would tie into would be older frameworks that have literally been there from 10.0, like the first version. And these are like core deep layer frameworks. So you're talking things like security, core graphics, some of the non-framework code that's part of OS 10 is in there. There's a lot of dynamic libraries that are standalone, not embedded in a framework. libcrypto is a more recent addition that's shown up. No, actually, libcrypto's been there for a while, but the liblzma and libarchive are relatively new ones on there. And also the private frameworks, the ones that Apple has that are part of the operating system that do really nice, useful things, but they don't provide public API frameworks for. With Ctypes, you can access some of that stuff. So is it for you? So this is really, so Tim's talk that he just did with Python was if you've never done any Python before, sort of introductory to it. If you are already heavily invested in doing Python for your Mac administration coding needs, Ctypes, you may end up having to use it at some point here. But check for command line tools that do the job first. There are some decent ones that it may just be easier to wrap the Python sub-process module around and just launch the command line tool and pass the arguments to it. But if you need a little bit more control than that, say you're having to try and use the security tool to go look through your keychains for a certificate, security tools, horrible for that. The security framework, however, is all written in C. So you need Ctypes to actually do anything really useful out of it. But it's much less forgiving. C language lets you poke directly into memory and do horrible things. So you need to be very careful about how you're writing your code. Like this is another thing. If you're already doing PyObjective-C, you may have actually run into this particular error message before. PyObjective-C will throw this when you attempt to access a C function from PyObjective-C. It says, I'm going to give you a raw pointer back. It's scary. I don't know what to do with it. That's a warning to you that you may want to start looking at Ctypes because you've crossed the line now. You're already halfway there. So I'll give an overview here of what it kind of looks like to use Ctypes. It's not terribly scary, just to start diving into it. So for the Python module Ctypes, you just import CDLL, and then you pass it a path all the way down to the internal part of the framework. So it'd be like system, library, frameworks, security.framework / version / current / security, like this huge long path. Or if you import one extra thing, ctypes util find library, you can just say import find library system, and it will find the path for you and walk all the way down. It's a nice, quick, easy way to do it. And then once you've imported it, you assign it to a variable, and now that variable is your C library. You can start running functions off of it. That's literally the bare minimum that you need to do to use Ctypes. Just import it with CDLL, and then start calling functions. But it's very raw access at that point. The operating system doesn't know what that function does. It's assuming you know what it does. It's assuming you're passing it the right number of arguments that are the right type. So Ctypes actually provides the capability to define those to help the operating system make sure that you're passing it the right things. So you can import lots of different data types. Like that one up there is a unsigned 32-bit integer. Python has automatic conversions between all these various types within the Python language itself, but with Ctypes, you generally need to be very explicit about the types of objects you're doing. So if you were to import some C library and bring it in, you can say the res type or the result type is an unsigned 32-bit integer. And now Python knows, okay, so when we run a function and we get a result back, I should express the result in terms of an unsigned 32-bit integer. It also has the capability to do lots of other types that are in there. There's character pointers, void pointers, all sorts of stuff that you can also specify the arguments for the function and say the function argtypes are, oops, there's actually a coding error in there. I should have said some lib dash, anyways. Argtypes, and then you pass it in and say the first argument is a void pointer and the second argument is a normal signed integer. And then, in this instance, the return type is a character pointer on there. So I kind of wanted to give you an idea, like a taste of some of the things that you can do with it if you decide that it's something interesting to look at. So I mentioned earlier older OS X frameworks, so security and core graphics. Core graphics is one. So recently, well, not recently, actually for the last few versions, if anyone's been doing, basically it was what, since 10.7, since Lion, since they really started changing the graphical engine within OS X and start doing the core animation and start getting all those cool visual effects, Mavericks is really heavy with that. If you are the type of person who is doing your testing with OS X in a VM, you may have noticed that the most recent versions of OS X are really pokey in a VM, very slow graphically and visually. And so some enterprising, wonderful person realized that the Quartz debug tool that comes with developer tools had the capability to disable beam sync, to disable essentially the reason that the graphics are so slow is that Apple wants everything to look pretty. So they wait for all the graphical changes to happen, and then they synchronize one entire update of the whole screen at one time. And they want to, on a hardware device, they want that to run at 60 frames per second. In a VM, you don't rate that. So it waits till all the changes happen and get composited into one frame, and then it draws the frame. And in a VM, that causes your performance to just fall through the floor. And so Quartz Debug allowed you to hit a little radio button that says disable the synchronization just as soon as a graphical change happens, draw it on the screen, and suddenly everything is much more snappy and responsive on there. And the key behind that was the Core Graphics Framework. The Core Graphics Framework has some not documented functions in it for doing that little radio button thing that the Quartz debug does. And those functions are called CG set debug options and CG set deferred updates. So with Ctypes, you can actually import the Core Graphics library and then access the debug options and the deferred updates and do the exact same thing that Quartz debug does. And now that you've got it in a script, you can turn it into an automated startup process included in your VM builds. So all of your builds automatically set debug the refresh disable sync, and so now all of your VMs, the graphics are suddenly much snappier. That's one very practical application that's come out recently. In fact, Rich Troughton actually had a write-up on it. He was referencing initially a compiled command line tool that did this exact same thing, that eventually VMware themselves started referring to as the best way to get graphics performance out of OS X VMs right now, instead of, writing a decent graphics driver or something like that. And let's see, other examples would be, the biggest and the baddest is the security framework. So if you ever find yourself for having to manage keychains, it is a nightmare. The security tool the command line tool is not very pleasant at it. The keychain operations are all in the security framework. They are all C functions. Security framework also covers a lot of different types of authentication mechanisms, and certificate and trust services are in there. I have an example here. I think I was working with you, Sam, on this one. Yeah, so you'll notice in here, depending on when I wrote this, see, I did that huge long path thing on this one. Eventually, I stopped doing that as I realized more and more about how to do the C-types on here. But this tool here was for, Sam was working on trying to enumerate all the default encryption options that OS X actually provides out of the box when wanting to communicate with websites, basically. There's a lot of different cipher encryption options that are available. And if you go to the documentation that Apple has, they list this huge list, but not every single one of them is actually enabled by default on an operating system. And it varied from operating system to operating system. So if you were trying to do an enterprise internal web app of some sort and you wanted to have the highest layer of security that was available for a certain collection of operating systems, you needed to be able to enumerate what encryption options does this operating system use or want to use out of the gate. And so this piece of Python here wraps around the security framework, and it uses a function in here which is SSL get enabled ciphers, and it actually dumps the whole list. So it became a Python script that you could just run on each of your Macs, and it would dump all the default enabled ciphers for that particular OS X version, and then you can do comparisons across the versions and say, okay, this is the highest layer that's available on all of the OSs that we support. Again, that function, not available unless you're using C-types or C wrappers. So those are OS X frameworks. There are, like I mentioned, standalone dynamic libraries that are also shipped with OS X that live outside of frameworks. The user lib directory on your computer is a great place to go look at a whole collection of them that ship with your box. If there isn't an API for doing something very common, oftentimes it's dealing with different types of data, data containers of various sorts, you might want to check with the OTool command against the command line tool that works with that type of data, like packageUtil or whatever, and say OTool-L and pass the name to the command, and you can see a dump of all the things that it links against, like all the frameworks that it links against, and you may see standalone dynamic libraries that show up in the list. So in this case, it links against a standalone libzar, which is a ZAR file handling library. So it contains all of these functions for natively working with ZAR files. So I did that for Pepine, who's not here, Pepine Duran, very cool guy. He was working with a process where he was trying to natively inspect packages. Tent specifically Yosemite and later packages, the operating system installer packages, because he was trying to inject them into netboot images and extract contents from them. And the problem is that Apple changed the internal structure of those files and added the new XZ compression format. There are no XZ APIs in OS X at all, none. But there's a dynamic library that's included with OS X for working with it, so that I wrote a Python wrapper around that dynamic library that allowed him to programmatically inspect a package and extract contents from it, where basically a command line tool for actually just decompressing an XZ file doesn't exist on OS X. There's no actual command line tool or public Apple API for it. The library is just sitting there in a folder on your box waiting for you to use, but you have to write code that links against it. And so using this, he was able to basically make his tool automatically unpack the OS X installer media and extract certain frameworks and embed them in a netboot image so that it became more useful. You could run more applications out of the netboot image. This one here, and I think this is Mosen. I can't remember who I did this one for. Yeah, this one, you can do other interesting things with it too. Like this one wraps against the libcrypto library and allows you to decrypt the on-disk stored encrypted deploy studio credentials for your deploy shares. So it's they have an embedded private key in Deploy Studio. So all your settings are encrypted on disk. So if for some reason you forgot what you had in there and you wanted to extract your password back out, this tool can do that. And this is the one that I really like to do a lot. There's an entire directory on OS X. There's system library frameworks, which is all the public stuff. And then there's system library private frameworks, which is all the private stuff. There's useful things in there. Apple has tools in there, but they don't give you handles to tweak with them. So yeah, this is Apple's private stuff. It's really not recommended that you depend on code running with private frameworks, because Apple, since they don't make it public, they can change it at will. But sometimes they have these really handy utility functions that are embedded in there that if you could just get access to it, it would save you a whole lot of work. I mean, it's literally the tools that Apple themselves is using internally. If they've already done all the work up front, why not just kind of leverage that for a bit? An example here, this is kind of a silly, trivial example, but some people who maybe have to deal with Adobe Creative Suite at all and that horrible Apple Java Runtime 6, there's actually an internal private function that is the Apple function for determining if Apple Java is installed. And it's literally JL is runtime installed. And it just returns a true or a false. And I was wondering how that lovely dialog that pops up in front of your face that says it's not installed and it's really annoying and all that kind of stuff, was there a point where I could get that to happen without triggering the dialog? Because that's the key. If you call the Java command line from a script or something and it's not installed, you get this stupid dialog that pops in front of your face. I wanted to get the step before the dialog popped. And in their private frameworks called Java Launching, they have this wonderful hidden function there. Mind you, this is a really limited useful utility right now because the entire Java VM framework is gone, now out of El Capitan. Yeah? No? Okay. But it's an example of some of the things that Apple wrote internally to make that, to do the dialog pop at you. They have a function that they call that says, is it installed, that someone wrote all the code to do all the proper detection. Now you can detect the same way Apple detects and then integrate that into your scripts. What was that more on that? Oh, yeah, so this one, so the defaults command, again mentioned in the earlier talk from Tim, defaults command is for manipulating system preference settings. The defaults command does a really cool trick that's not in the Apple APIs. The defaults command can look at preference settings for Mac App Store apps. There's not an API for that. The API allows you to access OS X applications, but not Mac App Store app preference settings. There is a hidden function for that. CF preferences copy application map. The CF preferences copy application map is the one that defaults uses internally. It's an undocumented function there. if you are managing Mac OS X, Mac App Store apps, and pushing it out to boxes, or you just want to inventory them and see settings that might be in these particular applications, the CF preferences copy application map function can get you direct access to it in a programmatic fashion, very similar to the way the default command line tool does. So there's other cool things that I like about Ctypes other than accessing the private stuff. It has what's called the structure class. So this is necessary for Ctypes because the C language is not an object-oriented language. It doesn't have the concept of things like a named thing that has code that you run off of it or whatever. Everything is either a function or it's a data type or something along those lines. So the structure class from Ctypes allows you to build data types that say there are 64 bytes, and the first 10 bytes are this, and the next bytes are that, and you can give them all names, and then it becomes easy to access them. Now you can reference them by name. I use it for, I don't really have it on here. That piece of code is a horrible piece of code that you should never use, but it's a great example of it. That guy will build from scratch, raw, in Python, a Mac OS X alias file complete with resource fork that can mount an AFP share from the dock. You know, the kind that you put in the dock and it's nice and you click it and it just opens up the window to the network share. That's pure Python code that will make one of those. You just provide the server name, URL, and the share name, and it will generate a whole one for you. It uses structures a lot because the alias file structure is a very complicated file structure, and so I put the structure class in there so I could just reference it like, this is the part that's the URL, this is the part that's the server, this is the part that's, it's a very scary piece of code to look at, but it's a very good example of structure. Also, there are limits to C-types. Like PyObjective-C gives you access to public APIs. C-types get you access to some private and hidden APIs. But beyond that, there's literally the way that OS X is actually architected. There are literally pieces of it that are just very difficult to access from Python in general. Some pieces of OS X want an app to be accessing it. And one of those examples is like XPC services. They really want to be talking to another application. It's inter-process communication between two applications. They don't handle real well when you're coming from Python to do it. Objective-C blocks. Sometimes to call Objective-C code, you need to pass a piece of code to that code. Doing it from another language entirely, from Python, don't even bother. There literally are limits. At some point here, you need to go, okay, that's it, cool. We're going to go write actual raw Objective-C code here. But if you're interested in this kind of thing, recommend definitely learning about the C language itself. It's a whole other universe out there. It's very different from Python or Objective-C. Hopper, can't say that enough. It's a decompiler tool, a reverse engineering tool. It's really awesome. It lets you inspect all those private frameworks and go spelunking for private code. Unfortunately, a lot of the results it gives you are assembly code, so learning a little assembly probably wouldn't hurt either. I know, it's kind of a lot to say, but and then you can come hang out with us crazy people on OS X server on Freenode and fire questions at me on Twitter and stuff like that. But other than that, yeah, that's it. I hope you're interested.